So, good morning. In today's session, we have to study about the numericals for Thevenin's and the Norton's equivalent circuit. So, here, if you see, these guys have discovered Thevenin and Norton's theorem. He has published. In this module, we can learn about the theorem which will convert any linear complicated network into a simplified circuit where we will get one voltage source that will be in series with the current source, or we will get the circuit where we will get one current source and that will be in parallel with the same amount of resistance that is in series with the voltage source in the Thevenin equivalent. So here Thevenin में हमें मिल रहा है एक voltage source, उसके साथ series में Thevenin equivalent resistance, और Norton's में हमें मिल रहा है shunt current that will be in parallel with the Thevenin equivalent resistance. If there is load given at that time, we can connect that load as it is to the output. So here we can see Thevenin theorem. It will apply to the circuit which will contain lots of energy sources. The energy sources that will be voltage or that will be the current. We can convert that circuit into a simple, simplified Thevenin equivalent circuit where we will get one voltage source. We can call that voltage as a Thevenin equivalent voltage, or we can say that voltage as a open circuit voltage because we are considering this as a open circuit. If there is load given at that time, you are supposed to connect that load at the output. And if they are not giving, you can consider kept the circuit as it is. So here, what we are saying, if we are having any network that is complicated, in which we are having lots of resistors, we are having lots of energy sources that will be voltage or current. At that time, Thevenin theorem states that a resistive circuit in which we are having complicated network, we can convert that into a simple one voltage source and a one resistor like this. We can convert this circuit into this circuit. So here, what we are saying? We are saying here, if we are having the set of terminal, like we have studied in our third unit, that is nothing but two port. So what we are saying, a set of two terminal, we are saying these are as a port. So here we can convert complicated circuit into a simplified circuit because we are considering here only one voltage source that will be in series with the resistor. So here, if we are having the any network which is having a port, if it is having two terminal, we are saying it is a port. So here any two terminal that can be designed as a port. So here we are supposed to find the equivalent circuit by looking into a port. It means what? Here we are supposed to convert that circuit into a circuit where we will get only one voltage source and one resistor. If you see, here we are having voltage, here we are having two resistors. So here we can define a port. This is nothing but these two terminals. We can define port, so we can define the voltage across that port will be Vx and current flowing through that port will be Ix. So here we can say if we are connecting here load that will be in series with this port, so we can say that current will flow to some load at that time. According to the KVL, if you are applying KVL to this loop, how will you get? You will get VO equal to I1 R1 plus I2 R2. We have already seen KVL and KCL. So you guys are aware about. You can use any method. You can use load analysis. You can use KVL, KCL. What we are supposed to do here, if they have given the voltage, we can find the value of current. And if they are given the current, we can find the voltage value because here we are supposed to convert that circuit into a simplified circuit where we will get only one voltage and one current. So here, if we are considering this point as a node, I1 is incoming, I2 is outgoing, Ix is outgoing. So according to KCL, you can take incoming equal to outgoing, I1 equal to I2 plus Ix. So here we will get the value of voltage across the load. That will be Vx equal to, that will be in parallel with this R2. So you can take that Vx equal to the voltage which will be across this R2. You can take I2 R2 because in parallel voltage will be same. So here when we will get these equations, जो equations पहले मिले हैं यही equations मैंने फिर से लिखे हैं. When you will get these equations, you we are having the equations for current, we are having the equations for the voltages. So here if you are writing the Vx value in the in these equations, if you are writing the value for the Vx in the form of I2, your equation will become this. ये क्या है? I1 R1, I2 R2. I2 R2 you can write as a Vx, but Vx we know Vx is nothing but I2 R2. So if you are writing the value for I2, that will become Vx into R2. So if you are writing here Ix और I2 की जगह मैंने लिखा है Vx by R2. R1 as it is. I2 R2 we know this is nothing but Vx, Vo as it is. So if you rearrange these equations, you will get the value for Vx. That will be Vo into R2 upon R1 plus R2 minus Ix R1 R2 upon R1 plus R2. I have written here. What we are supposed to do? Only we are supposed to apply KCL, KVL. After that, जो equations मिल रहे हैं, at that time, if you are rearranging these equations, if you are simplifying these equations, you will get the value for Vx. So here, what we are saying? We are saying we are supposed to convert that circuit into a simplified circuit where we will get only one voltage source and one resistor. So here we can see it has the form Vx equal to Vth minus Ix Rth. So here we can say Vth is nothing but Vo R2 R1 plus R2 and Rth is nothing but this R1 R2 upon R1 plus R2. Because if you see here, we are supposed to find the value for Thevenin equivalent. At that time, you can see these are in parallel because these are in closed loop. So here, if we are considering load, this will become parallel. You can take Rth equal to R1 R2 upon R1 plus R2. And if you use voltage divider directly to derive the value for voltage across R2, you will get total voltage VO into that resistance in numerator upon total resistance R1 plus R2. You will get the value for Vth, you will get the value for Rth. So we can convert our circuit into a simplified circuit. And you can write the equations which will be for Vx. That will be Vth minus Ix Rth. So here we can say output voltage is nothing but that is the given voltage minus voltage drop across resistance, because when we are giving the voltage at that time some amount of voltage will go through drop, potentially drop through the Thevenin resistance because there are lots of resistors. So here we can solve this like Thevenin equivalent circuit. We see some examples here. So here, when we are having the actual circuit, the same circuit I am writing, what we are saying, we can convert that into this form, where we will get equation Vth minus Ix Rth. That is nothing but the voltage drop that will be across Rth. And what we are saying, when we are giving the voltage, at that time some potential will drop across the Thevenin equivalent resistances. Thevenin equivalent resistance, जो भी रेजिस्टेंसेस है वहां पे उसके अक्रॉस में ड्रॉप होगा वोल्टेज का जब हम वोल्टेज देंगे. सो यू विल गेट द इक्वेशंस फॉर Vth Rth here. Now if we are having the circuit in which we are having this board, we can convert that circuit into a Thevenin where we will get these values are here. If you see, these are the parallel, and if you use voltage divider rule, you will get voltage across R2. That will be the voltage across that load resistance. That is nothing but Thevenin equivalent resistance. So here, what is the significance of RTH? We are calculating the equivalent resistance. How we are calculating? We are considering all independent sources in the actual circuit as a 0. So for a voltage source, we are keeping their short circuit. जो सप्लाई वोल्टेज दिया था यहाँ पे व्हेन वी आर सपोज टू फाइंड द थेवेनिन इक्विवेलेंट रेजिस्टेंस, तो ये जो वोल्टेज दिया है, if there is a voltage source we can keep this as a short, and if there is a current source we can make open to derive the value for Thevenin equivalent. So if we are making here short, तो सर्किट क्या हो जाएगा, ये R1 और R2 if you see both will connect to both sides, दोनों साइड के रेजिस्टेंस के जो टर्मिनल्स है दिस विल कनेक्टेड, सो वी कैन से दिस आर इन द पैरेलल, सो वी कैन कैलकुलेट आरटीएच, दिस विल बी R1 parallel R2. So here RTH is the equivalent resistance that is looking into the port where we are considering all independent sources which we are set to 0 value. So here when we are considering a voltage source that will be to the 0 value, at that time what we are saying, if there is a voltage source between the node which is fixed at the output voltage VO, and if we are supposed to determine the current, at that time we can make that voltage source as a short circuit. And here if you see the voltage between node, we are keeping this short circuit. We are aware about the voltage and current concept. If there is a short circuit, we know there is no voltage, so we can say if there is a short circuit we can take fixed voltage, that will be the 0 volt, and if there is a current source, at that time voltage between the nodes which we can determine by keeping that current source to 0. How we can determine? We can make that circuit as a open circuit. हम क्या कर सकते हैं, जहां वहां पे सर्किट है, जहां पे वहां पे करंट दिया है, we can make that circuit as a open source. So we will find the value of Thevenin equivalent resistance. So here we can say there are some significance of VTH. We can connect nothing to the port. We are considering IX automatically set to 0 by making the circuit open. Port voltage is called as a open circuit voltage, because here if you see we are only taking the voltage and resistor which is having the open circuit. So here we can say that port voltage as a open circuit voltage, or we can say Thevenin voltage. So Thevenin voltage represents the same voltage, that is nothing but the open circuit voltage of the actual circuit. So here we see some examples. If we are having the circuit, here they have given the value for R2, R3, R1. Input voltage they have given. Here they have given the value for the load resistance. We are supposed to use here Thevenin equivalent circuit. How we can make Thevenin equivalent? When there is a load, there is no need to consider to define the value for the RTH and VTH. तो मैंने क्या किया है, जो यहाँ पे रेजिस्टेंस दिया था, लोड दिया था, we are not considering, we are taking it as a open circuit. So here when we are considering it is as a open circuit, we can disconnect the load, find Thevenin equivalent, that is RTH and the VTH. Again we can reconnect that load to here and find the value of V load according to the voltage divider. So here if we are not considering this, now we are supposed to find RTH. How we can find? We can find from this side. So we can right side, we can make this voltage source as a short circuit. तो तुम्हें क्या हो जाएगा, 100 किलो ओहम और 30, these are in the, how these are in the parallel, क्योंकि यहाँ पे शॉर्ट सर्किट हो जाएगा, and where you will get one voltage, one resistance. ये पैरेलल का निकाल लोगे, you will get that value of resistance R1 parallel R2, and that will be in series with R3 and R4. So you will get the value for the RTH. You can see one by one we will solve. So here we can say if we are making this short circuit, R1 and R2 will become, and this will be in series with R3 and R4. So we can calculate the value of RTH. That will be 43 kilo. How will you find? 100 into 3 upon 100 plus 3 plus 10 plus 10. That will be kilo ohm. So you will get 43 kilo ohm. So here I have given here how we will get the values. 23 plus 10 plus 10. That will be 43. Now you are supposed to find the value of VTS, that is nothing but voltage which is flowing through the R2. How we can find? According to the voltage divider. R2 upon R2 plus R1. Because when we are considering not this load, at that time there will be no use of this resistor. Only we are finding the value of VTH. How will you get? V input 10 millivolt into that R2 upon R1 plus R2. If you put the values, you will get output voltage, that is nothing but not output voltage, that is the Thevenin voltage or VOC, that is nothing but 2.3 millivolt. So here we can say there is no current will flow through the R3 and R3 and R4 because we are considering this as an open circuit. So voltage across this will be 0. Now what we are supposed to do here? Here again we are supposed to connect load as it is to Thevenin equivalent circuit. हमने RTH का 43 किलो हम ड्रॉ किया था, VTH का 2.3 millivolt. You can put this value and you can write this. You will get the Thevenin equivalent circuit. So now, if you are supposed to find the V load, how will you find? If you see, we are having total voltage, we are having these resistances, so you can find according to the voltage divider, VTH upon VTH into RL upon RL plus RTH. You will get VTH is nothing but 2.3 millivolt into R load 50 kilo ohm upon 50 plus 43, that is nothing but 93 kilo ohm. If you solve, you will get the V load, that is nothing but 0.4 millivolt. So here we have finished about the Thevenin equivalent circuit. Now what we are saying for the Norton's equivalent circuit? Norton equivalent circuit is exactly similar with the Thevenin equivalent circuit, except there is, we will get current source, and that will be how we can find. If any circuit we can convert into a Thevenin after that by using the source transformation. We can convert voltage source into a current source. So here we will get shunt current, and that resistance Thevenin equivalent resistance will be in parallel with that. Otherwise, you can solve separately for the Norton equivalent circuit. If we are having the Thevenin circuit, at that time we can calculate the shunt current. How? Because we are making here load, that is we are disconnecting. So you will get the value for is, that is nothing but according to Ohm's law, V upon R, VTH upon RTH. So by using the source transformation, you will get the value, or we can solve by simple method. By using any method, you can solve the value for the ISH. But here you are supposed to find the Thevenin equivalent resistance, similarly which we are finding in the Thevenin circuit. So here we are saying another important parameter, that is nothing but the short circuit. Short circuit current of port is defined as the current will flow if load is disconnected and a short circuit is connected instead. So here when we are having the circuit, we can convert that circuit into a current source, and Thevenin equivalent resistance will be in parallel with that current source. So here we can find open circuit conditions, all of current flow through the R1. Because if you see here, only this current is connected to through this R1, and voltage develop across R1 will polarity show. So according to Ohm's law, we can take VTH is nothing but I1 R1. It means what? We can convert Thevenin circuit into Norton's, or we can convert Norton equivalent circuit into a Thevenin by using the source transformation, because directly we can use the Ohm's law to define the value of voltage if the current is given, and if voltage is given, we can find the value of current by like V by R. So here, what is our first step? We are saying find the open circuit voltage. After that, find the equivalent resistor. After that, what we will do, if we will get the value of RTH and VTH, we can convert that into a circuit where we will get the value of voltage. How will you get? Current का मिल गया है, so you can convert current into resistors, that will be the voltage. So here we can convert Nortons into Thevenin or not Thevenin into a Norton. This circuit is nothing but the Norton circuit. So here we are saying this is the Norton equivalent circuit. So we can say this is the Norton's current. And Thevenin, we can say that is nothing but VTH, or we can say that is the ITH into RTH, or we can say IN, RN. All are having the same meaning. But what is the difference? In Thevenin, we are converting complicated circuit into a simplified where we will get one voltage source and one resistance that will be in series with that voltage. But in Norton's, we will get the current source. That is the shunt current. And that resistance, Thevenin equivalent, will be same, which we are using in the Thevenin. But here, that resistance will be in parallel. यहाँ पे series में था, यहाँ पे parallel में है. So here, what about the short circuit current from the Norton circuit? If we are making that load as a short circuit, the voltage across Norton resistance becomes zero. So we can say there will be no current flow through the Norton's resistance. All current will flow through the short circuit. So here, if we are having the circuit Norton, we can convert that into a Thevenin equivalent circuit, and if there is load, we can connect that load at the output. We can solve one example, so you will get the things. Okay, so here, if we are having the network, find the Norton's equivalent of the following circuit using the short circuit current method. This is nothing but the Norton's theorem. So how we can use short circuit means you are supposed to understand a short circuit. Open circuit means Thevenin. Sometimes they will give directly the name. You can solve the equivalent by using short circuit, by using open circuit. Sometimes they will not use here Norton or the Thevenin. Sometimes they will directly use. Find the equivalent of following circuit using short circuit. Short means ITH parallel with RTH, and open means VOC series with RTH. You are supposed to understand the thing. So here we can find RTH. If there is short circuit, we can consider R1, R2 are parallel, that are in series with 10 kilo ohm. 10 kilo ohm जैसे हमने अभी डिराइव किया था, क्या आया था वैल्यू 23. So 23 plus 10 you will get RTH, that is nothing but 43 kilo ohm. So here same circuit I have taken जो हमने RTH इसमें लिया था, Thevenin में लिया था. So here we are supposed to apply the short circuit to the port. Now we are supposed to apply here short circuit. So here when we are applying short circuit, at that time you will get the values for current. How will you get? We can use here current divider rule or voltage divider rule. We can find firstly if you find the value of voltage, you can apply again Ohm's law. You will get the value for current. So here where we have find the value, जैसे हमने पहले से solve किया था, I have taken directly the values here. I have written here. But how will you find? We can use here current divider. Current divider rule, how we can use total current into parallel ka current. That is nothing but you are supposed to find here. So you will take R2, that is in parallel, upon total resistance. That is nothing but R2 plus R3 plus R4, because ये तुम शॉर्ट कर रहे हो, you are supposed to consider all these. But वहाँ पे हम इसको open consider कर रहे थे. At that time, no need to consider R3 and R4. But in Norton's, प्लीज अंडरस्टैंड द थिंग, आरटीएस डिराइव कर रहे हो तो सेम है नॉर्टन्स और थिवेनिन में, बट व्हेन वी आर डिवाइडिंग, व्हेन यू आर कैलकुलेटिंग द वैल्यू फॉर करंट, एट दैट टाइम यू आर कंसिडरिंग लोड एज अ शॉर्ट सर्किट. एट दैट टाइम व्हेन यू आर यूजिंग द करंट डिवाइडर, तो उसका न्यूमरेटर तो that will be the parallel resistance, but denominator that will be the total. So total में क्या आएगा, R3 R2 plus R4. So if you see, you will get the value for IP. How will you get? Because they have given the voltage here. So we can calculate IP equal to voltage upon total resistance. If you see here, these resistances R2, R3 and R4, these are in series. So 10 plus 10, 20 kilo ohm. 20 and 30 in parallel. 20 into 30, 600 upon 20 plus 30. That is nothing but 50. 600 upon 50. You can calculate. You can write that value here, and that will be in series with this R1. So I can calculate directly according to the Ohm's law. और ये कैसे calculate किया है, ये मैंने अभी जैसे बताया है. These are, if you see, we are using the short circuit. तो R4 R3 series में, तो 10 plus 10 बनेगा 20. That will be in parallel with 30. You can calculate RP. And that will be in series with this 100 kilo. ऐसे सर्किट आ जाएगी. So according to Ohm's law, you will get the value for the IP. और जहाँ पे तुम्हें total current मिल जाएगा, you can use current divider rule. You will get the value that is nothing but 0.54 microampere. That's why I have written here. Firstly, you are supposed to calculate. After that, you can draw the diagram and you can write the answer. Okay. So here, what we are saying, now we have find the value for IS, that is nothing but the short circuit current, or you can say ISH, short shunt current, any, or you can say IN, Norton current. You have calculated RTH को तुम RN भी बोल सकते हो. So if you are calculated, you can draw the diagram and you can write. If you are writing the value for current and resistance, and there is question, you are supposed to find VOC by using the Norton. So you can calculate. Here they have given directly one resistance and one Norton's current. जैसे तुम कॉम्प्लिकेटेड को सिंपल में डिराइव कर रहे हो, एट दैट टाइम एक रेजिस्टर है, एक करंट है, these are parallel. So you can see that current will be flow whole through this resistor. So you can directly calculate voltage according to Ohm's law, IR. You will get 0.54 microampere into 43. If you check at that time also, you will get 23 millivolt. तो यहाँ पे भी वही मिलेगा तुम्हें. Here we have finished how to find the value of Thevenin voltage, how to find Norton's current, and how to find Thevenin equivalent resistor. When you will get the value, you can draw the diagram and you can write the answers. This result is same which we obtained in the previous example by using the Thevenin equivalent circuit. Here we have used Norton's. Here we have finished about the Thevenin and the Norton equivalent circuit. If anyone is facing any issue, you can ask me. Just wait for a minute, I will take your attendance. Okay. Thank you. You guys can leave now. Okay. Do the homework. Okay. And if you guys have not given the test, you can give. Test will be valid for the electrical circuit till today night. Okay. There will be no lecture on the Monday. Okay. Thank you. You guys can leave now. Thank you. Only for electrical and electronic circuit, I am telling. Remaining lectures will be there because I will not be there on the Monday.